Okay, continuing on with our discussion of finding derivatives, we talked about how to go about doing that with a constant, right? We can just take the constant out, find the derivative, and then multiply through by that constant. But again, as I said before at the very end of the last video, you don't need to write this out. This is the rule. Now that we know the rule, you can just go through and do that. So for example, if I had given you d dx of 3x to the 7th, then you can just write that as 21x to the 6th, right? You take that 7 and multiply it by 3, and then you decrease that exponent by 1. You don't need to show me work of how you got this. This is just all that you need to show because now you know the rule. Okay, now let's talk about another rule when we are dealing with functions that we are adding or subtracting. So we'll call them f of x and g of x. We actually can take the derivative of those functions separately. So d dx of f of x plus d dx of g of x. Okay, so for example, if I have d dx of 3x to the 9th minus x to the negative 3rd. Okay, the rule says that we can break those out, so I can do d dx of 3x to the 9th minus d dx of x to the negative 3rd. So if I do those separately, that first term ends up as 27x to the 8th. That second term would be negative 3 times that negative that's out in front, so it would be positive 3x to the negative 4th. And again, now that you know this is a rule, you don't have to write out this middle step. You don't have to show that you're taking the derivative of each part of that. You can just go right from the what's given to you right to this final answer. Okay, let's try another one. Let's say we have d dx of 4 minus 3 square root x. Okay, I'm going to write it out just for demonstration purposes, but again, you don't need to write out this middle step. Now, if it helps you to write it out, please go ahead and do that, but you don't have to. Now, remember, when we are doing these, right, we can't take the derivative with x in this form. We have to have it in terms of an exponent. So I'm going to just convert that square root x to the 1/2. Remember that the derivative of a constant is 0. And here I end up with negative, I'm doing 3 times 1/2. And then I have x, so if I subtract 1 from that, I get x to the negative 1/2. So I end up with negative 3/2 x to the negative 1/2, which is the same as negative 3 over 2 square root x. Okay. Now, this rule comes in really, really handy when we are dealing with really long equations. So let's say, for example, I gave you f of x is equal to 5x to the 7th minus 3x to the 4th plus 2x cubed plus x minus 1. And I asked you to find dy dx. And if you had to do it out the long way with the definition of the limit as h goes to 0 of f of x plus h minus f of x all over h, you'd probably be here until next week doing this one problem, right? It truly would be ridiculous the amount of work you'd have to put into it. But now with these new rules, we can go through this very, very quickly and find the derivative, right? So if we do this, we're just going to then do each term of our polynomial, take the derivative of each term. So I end up with 35 x to the 6th minus 12x cubed plus 6x squared plus 1, right? I have x there. The derivative of x is just 1, right? If this said 3x, then this would be 3 down here. If this said negative 17, this would be, or negative 17x, down here it would be negative 17, right? And then this is just the end part here. The derivative of negative 1 is just 0 because that's a constant. And that's your derivative. It's very quick, it's very easy, but it was important to go through those steps of the definition of a derivative with the limit explanation in order to understand what it is that you're doing, right? So this would be the derivative of that particular polynomial. Okay, so when you're dealing with polynomials, it's very straightforward finding the limit of each of those individual terms, right? It's getting into it's when we get into different types of expressions when you're dealing with rational expressions that it's a little bit different. So let me show you what I mean by that. That was a polynomial, but what if I had f of x? So what if I had f of x is equal to x to the 5th minus 2x minus 3 over 3 square root x. So now I'm dealing with a rational function, right? And if I put that in the right terms, that would give me x to the 5th minus 2x minus 3 over 3x to the 1/2. And wouldn't that be great if you could just do the derivative, or dy dx of x to the 5th minus d dx 2x minus d dx of 3, and then divide that by d dx of 3x to the 1/2. Right? That would be easy, but you can't do that. Okay, we're going to talk about quotient rules a little bit later on. But what we can do with what we know about I'll call this y. It doesn't really matter if you call it x or f of x or if you call it y. I'm going to call this y just for simplicity purposes. What you can do, what you know from algebra, is that when you have multiple terms in the numerator and a single term in the denominator, right, you can write that out as individual terms with that denominator in each term. So 1/2 minus 3 over 3x to the 1/2. And now what I can do is I can rewrite that. Remember, when you divide things with the same base, you subtract their exponents. So this first term would be 1/3 x, 1/3 x to the 9/2, right? Because 5 is the same as 10/2. So 10/2 minus 1/2 is 9/2. And that's just a little scribble in there that I did by accident. That doesn't need to be there. Okay. Then we have minus 2/3 x to the 1/2. And then I have negative x to the negative 1/2. So all I did here was simplify. Simplify each of these terms to make it differentiable, right? To make it easier to differentiate. So now when I do dy dx, I end up with, right, 9/2, so 1/3 times 9/2 x to the 7/2, because I have to subtract 1 from that, minus 2/3 times 1/2 x to the negative 1/2. Okay, now I would have plus 1/2 x to the negative 3/2. And so if I simplify that, right here my 2's cancel. So I'm left with 3/2 x to the 7/2 minus 1/3 x to the negative 1/2 plus 1/2 x to the negative 3/2. And that would be my answer there. If you wanted to write it in with radicals in it, you would write that as 3 square root x to the 7th over 2 minus 1 over 3 square root x plus 2, plus 1 over 2 square root x cubed. That's a cubed on the end there. Okay, so that would just be another way to write that out. So it's a little bit different when you're dealing with polynomial functions versus rational functions. Just basically turn that rational function into something that resembles a polynomial function, and then you can follow your rules of differentiation. Okay, one other problem that I do want to talk about briefly is when we're asking or when we're talking about horizontal tangent lines. So for example, at what points does y equal x cubed minus 3x plus 4 have horizontal tangent lines? Okay, this gets into the idea of relative maxima and minima, which we will get into eventually. So let's first find the derivative, dy dx, and we can do that very, very easily now. That would just give us 3x squared minus 3. Now, remember that the derivative is the slope, right? That's what it means to find the derivative. You're finding the slope of a curve at a point. So this is the formula for the slope. In order to find where my slope is horizontal, remember that in a horizontal line, your slope is 0. And so now we're just solving the equation for x, right? So I end up with x minus 1 times x plus 1 is 0. So I get x is 1 and x is negative 1. Now remember, those are just your x values. Those are the x coordinates of your points that you're trying to find. I need to plug those back in. Be careful, you're plugging those back into the original equation. Okay, you're not going to plug it into the slope formula. You want to find the point on the curve. So when x is 1, what does y equal to? When x is 1, you're just substituting that into the equation. If you do that, you end up with y is 2, and when x is negative 1, you end up with y is 6. And so your 2 points where you have horizontal tangent lines would be at 1, 2, and negative 1, 6, right? Meaning this, you have some function here. Here's your horizontal tangent line, and here's your horizontal tangent line. And I did not do those, exactly right. This is just for demonstration purposes. That's what it means. Okay, hopefully that helps. And next time we'll start talking about higher order derivatives. Take care.